Today we are going to present the topic air breathing engines and inlets. First, what is the air breathing engine? An air breathing engine is a type of engine that uses the oxygen in the Earth's atmosphere to oxidize or burn fuel rather than carrying an oxidizer on board. This engine takes in air from the atmosphere, compress it in the compression, and then mix it with the fuel and ignites the mixture of air fuel mixture in the combustion chamber and then expel the hot gases to the exhaust to produce thrust. How the air breathing engine works. The air intake, air is drawn into the engine from atmosphere. Second stage is compression. Air is compressed into compressor, which increases pressure and temperature. Then third stage is combustion. Fuel is mixed with the compressed air and ignited. The combustion process releases a large amount of energy. Then fourth stage is exhaust. The high energy gases expand and expel out of the engine, creating that the propel the aircraft forward. Then the type of air breathing engines. There are several type of air breathing engines like turbojet, turboprop, turbofan, ramjet, scramjet, and pulsejet. The main difference between air breathing engine and non-air breathing engines are that air breathing engines can get the oxygen or air from the atmosphere, and the non-air breathing engines are carrying the oxidizer on their board for carrying the combustion. And the first type of air breathing engine is turbojet engine. A turbojet engine is a type of air-breathing jet engine and one of the simplest form of jet propulsion. It converts air and fuel into powerful thrust, propelling the aircraft forward. The working of turbojet engine. The first stage of the turbojet engine is intake or inlet, in which the air enters the engine through an intake through an inlet. Then the second stage is compression. The air passes through a series of compressor blades which compress and increases its air by the help of stator and rotor. Then the third stage is combustion chamber. The compressed air is mixed with the fuel in the combustion chamber. The mixture is then ignited, causing a high pressure and high temperature reaction. Then the fourth stage is turbine. A high energy gases from combustion passes through a turbine. The turbine blade extracts some of the energy to drive the compressor. Then last stage exhaust. The remaining hot gases exit the engine at high speed. The exhaust nozzle producing thrust. In the turbojet engine, the compressor is drive with the help of the turbine. Then second, turboprop engine. A turboprop engine is a type of air-breathing jet engine that combines elements of both jet engine and propeller-driven engine. It uses a gas turbine to drive a propeller, producing thrust more efficiently at lower speed. It is same as a turbojet engine, but the main difference is that it has a external propeller by which the thrust is generated more. It then it's working. It is also first is inlet. The inlet by which the air is taken inside of the engine. Then compressor, by the different stages of compressor, the air is get compressed. Then in combustion chamber, the compressed air is mixed with fuel and ignited. Then in turbine, the turbine extracts the energy from the compressed gases, from the high temperature gases, and with the help of the shaft, the turbine runs the propeller. The turboprop engine are known for their fuel efficiency and are commonly used in regional and short-haul flights, as well as in some military aircraft. They are most effective at lower speed and altitude compared to pure jet engines, making them ideal for smaller commuter plane and cargo aircraft. Third is turbofan. A turbofan engine is a type of air-breathing jet engine that is commonly used in commercial airlines and some military aircraft. It combines the principle of a turbojet engine with an additional fan at the front, which provide extra thrust and improve fuel efficiency. The working of the turbofan engine is same as the turbojet engine. The difference is it has a big fan attached at the frontal area, by which the more the intake area of air is increases, and the remaining working is same as that first inlet. Then second it has low pressure compressor which compress the air at some level, and then high pressure compressor. After that it has combustion chamber by which combustion happens, and then high pressure turbine which drives the high pressure compressor, and low pressure turbine which drives the low pressure compressor. After nozzle, and in this fan we can also add some it has also extra thrust by the fan. Then ramjet engine. A ramjet is a type of air-breathing jet engine that operates using the aircraft's high speed to compress incoming air before combustion, making it unique compared to other jet engines. It doesn't have any turbine or inlet, or it doesn't have turbine compressor. It has only a simple shape in which it has air inlet, combustion chamber, and then nozzle. Its working is air intake. Air is rammed into the engine at high speed due to forward motion of aircraft. Then it has no moving part involved in it. Then compressor. The incoming air is compressed by the shape of intake and the high speed flow by the aircraft is traveling. This increases the pressure and temperature of the air. Then combustion chamber. Fuel is injected into the compressed air and ignited in the combustion chamber. The high energy combustion process generates hot gases. Then exhaust. The hot gases expand and are expelled at high speed through a nozzle, producing thrust. Then scramjet. Scramjet is a specialized ramjet engine, which is a scramjet stand for supersonic combustion ramjet engine. Is an advanced type of air-breathing jet engine designed to operate at hypersonic speeds, which are speed greater than Mach 5. Scramjet are a significant evolution of ramjet with key difference and enhancement that allow them to function efficiently at this extremely high speed. The working of scramjet is air intake. Air enters the engine at high speed due to aircraft forward motion. Compression. The incoming air is compressed by the shape of intake, which causes a significant increase in pressure and temperature. But unlike ramjets, the air remaining at supersonic speeds. In combustion, fuel is injected into the compressed supersonic airflow and ignited in the combustion chamber. The combustion occurs at supersonic speed, which is a key feature of scramjet. The last stage of scramjet is exhaust. The high energy gases are expelled at high speed through a nozzle, producing thrust. A difference between the scramjet and ramjet are the scramjet after the air enters into the ramjet, the inlet is type of which compresses the air for short period, but in scramjet the air is compressed after after intake is long. That why it compressed until uh, it compressed, and then after combustion the air it takes the supersonic speed. Then the last is pulse jet. A pulse jet engine is a type of air-breathing jet engine that operate using intermittent combustion to produce thrust. It has a relatively simple design and was one of the earlier form of jet propulsion. Its working is the air enters the engine through an intake valve. Then combustion, fuel is injected into the air and ignited in the combustion chamber. This creates a rapid, intermittent explosion of hot gases. In exhaust, the high pressure gases are expelled through an external nozzle, creating thrust. In this pulse jet, an engine is designed as the type that it has a high pressure valve. After the pressure is not attained, the valve is closed, and after the pressure attained, the valve open and the exhaust gases are expelled out. It is a type of engine which is done in the combustion in a pulse form. As one time it get the combustion, then stop for increasing the pressure. The key feature of a pulse jet engine is a cyclic or pulse combustion process. The intake valve closes during combustion. An explosion of gases create a pressure wave that pushes the gases out of exhaust nozzle. The process repeats rapidly, producing a series of thrust pulses.
So now we are going to study inlets. What is the inlets? Inlets, also known as air intakes, as crucial component in air breathing engines. They are designed to capture and direct airflow into the engines, ensuring efficient combustion and thrust generation. Types of inlets. There are two types of inlets: subsonic inlets and supersonic inlets. Subsonic inlets. Subsonic inlets are designed for the aircraft that operate below the speeds of the sound. These inlets are crucial for ensuring efficient airflow into the engine, optimizing performance and minimizing drags. Here are some key features of a subsonic inlets. Smooth curves. The subsonic inlets typically have a smooth continuous curves to ensure the steady and uniform airflow into the engine. Thick leading engine. The leading edge of a leaf of the inlets are relatively thick to capture the efficient and the reduce the risk of a flow separation. Low speed optimization. These inlets are designed to perform well at a lower speed, making them ideal for commercial airlines and other subsonic aircraft. Minimal flow distortion. The design aims to minimizing flow distortion and the pressure losses, ensuring that the engine receives and the stable airflow. Subsonic inlets are commonly used in commercial airlines and military aircraft that operate at a low speed. They are designed to provide optimal performance and efficiency for the aircraft flying below the speed of sound. Then the types of subsonic inlet. First is in pitot inlet. Second is divided inlet. Third is nickel inlet. Then second one is a subsonic inlet. Subsonic inlet are designed for the aircraft that operate at a speed generate than the speed of a sound Mach 1. This inlet have specialized features to manage and compress the high-speed aircraft efficiency, ensuring a optimal engine performance and stability. Manage a shock wave. Control the stabilize the shock wave that from the subsonic speeds to ensure efficient and compression. Optimize airflow. Ensure that the airflow entering the engine is steady, uniform and at subsonic speed for the optimal combustion. Adapt to speed changes. Use the variable geometry to maintain the efficiency across a different flight speed and condition. Thank you.